A business manufactures light bulbs and sells them in boxes of 50. Let P denote probability that a bulb is defective. Events that different bulbs are defective are independent. Let X denote number of non-defective bulbs in a box of 50. In addition, let n be the integer such that probability x greater than equal to n is greater than equal to 0.95. Determine which of the following statements must be true. So we are given that P is the probability of a bulb being defective, but then X is a variable which denotes the non-defective bulbs. And so we need the probability of non-defective bulbs, and that is a binomial variable. So if P is the probability that a bulb is defective, then the probability that it's not defective is 1 minus P, and therefore the non-defective bulbs, which they are calling as X in a batch of 50, will be a binomial variable with success probability 1 minus P. Remember, normally our success probability is P, but in this case, since success is being non-defective, so 1 minus P will play the role of the usual P in the binomial formula. Because remember, after all, P is the probability of success, and in this case, the probability of success is 1 minus P. And therefore, the probability of failure will be P, and therefore the binomial probability function in this case would be NCX, N is 50, X is the number of successes, and we just said that the success probability is 1 minus P in this case, so we'll have 1 minus P power X, because in the binomial formula, it's success probability raised to power number of successes. That's why we'll have 1 minus P power X, and the failure probability is P. So that will be power n minus x or 50 minus x. And we are talking about probability x is greater than equal to n in the problem towards the end of the problem, probability x greater than equal to n. So that is probability of x equals n plus probability x equals n plus 1 and so on up to probability x equals 50. So that is basically the summation of fk from k equals n to 50. And fk, if we substitute k over here, will be 50ck, 1 minus p power k. We're replacing x by k, probability 50 minus k. And we know that NCR equals 50 n factorial. So in this case, n is 50, so it'd be 50 factorial divided by the k factorial times 50 minus k factorial. That's the basic definition of combination of NCR. NCR equals n factorial over so we can look at the formula sheet that I provide for this set of problems. So here, like we have NCR equals n factorial over r factorial n minus r factorial. So go back. That's why this would be 50 factorial over k factorial times 50 minus k factorial. And we repeat the other two expressions, 1 minus p to the k and p power 50 minus k. So we are talking about probability x greater than equal to n is greater than equal to 0.95. So probability x greater than equal to n is all this sum. So that means this sum is greater than equal to 0.95, and that is choice A. If you look at the answer choices,